Welcome back to Physics Daily, your go-to source for exploring the fascinating world of physics in our everyday lives. Alright, we will talk about something that's more than a little twisted, the debate that's been circulating for centuries: is our Earth flat or round? But before we dive into it, make sure to hit that subscribe button and ring the notification bell so you never miss out on our latest video. Now, before you dismiss this as an already settled matter, stay with us. This isn't just about flat Earth theory, it's about questioning, exploring, and unraveling the mysteries of the universe. Is the Earth flat or round? Now, you might be thinking, seriously? We already know it's round. But hold on, this topic is more complex than it seems. Let's get started. We're all familiar with the well-established belief that our planet is an oblate spheroid, backed by centuries of scientific evidence. But did you know that there are individuals who fervently argue for a flat Earth? It's not a fringe idea, and it's not about dismissing established science, it's about daring to question and imagine beyond the boundaries of our collective knowledge. Susan Haack once compared knowledge to a crossword puzzle, and it's a perfect analogy. Our understanding of the world evolves as new answers interweave with old ones. The clues are the questions we ask, and sometimes, there might not be a single, definite answer. So, what's wrong with flat Earth theory? Well, it's based on the idea that the Earth is not a globe but a flat, disc-shaped object. Proponents argue that it's our perspective that makes the Earth appear round, and they have some intriguing arguments of their own. Flat Earthers believe that gravity, as we understand it, doesn't exist. Instead, they propose that the Earth is constantly accelerating upwards at 9.8 meters per second squared, giving us the sensation of gravity. They argue that this could explain why everything feels so normal on our flat disc-shaped planet. It's important to note that the flat Earth theory doesn't just dismiss all evidence of a round Earth. These theories often provide alternative explanations for phenomena like circumnavigation, lunar eclipses, and time zones. Here's where things get interesting. From the perspective of cosmic ray particles traveling near the speed of light, our Earth appears flat. Time slows down, lengths contract, and suddenly, our round Earth becomes flat to them. Now, let's address one of the most fundamental questions: why is the Earth more likely to be spherical rather than a flat, round disk? After all, the overwhelming scientific consensus supports the spherical Earth model. 1. Earth's shadow on the Moon. One of the earliest pieces of evidence supporting a spherical Earth comes from lunar eclipses. When the Earth passes between the Sun and the Moon, it casts a round shadow on the lunar surface. This shadow is consistently round, regardless of where the eclipse is observed on Earth. If our planet were flat, this phenomenon would be vastly different. 2. Circumnavigation. Another compelling argument is circumnavigation. When we travel around the Earth, we don't fall off the edge, as flat Earth theory might suggest. Instead, we seamlessly traverse the globe, returning to our starting point. This would be impossible on a flat Earth, where we would eventually reach the edge. 3. Ships disappearing over the horizon. As ships sail away from shore, they don't simply vanish from view all at once. They gradually disappear, with the deck being the last part visible. This observation aligns with the curvature of a spherical Earth. On a spherical Earth, this happens because, as the ship moves farther from the observer, it eventually reaches a point where the Earth's curvature obstructs the view from the bottom up. The curvature of the Earth hides the lower parts of the ship first, making the hull the last portion visible. Now, consider what would occur if the Earth were flat. In such a scenario, ships would appear to shrink uniformly as they moved away from the observer, with no specific part disappearing first. This uniform reduction in size, regardless of the ship's distance, is in stark contrast to what we observe in reality. 4. Stellar observations. Traveling north or south brings changes in the night sky. New constellations come into view while others vanish below the horizon. This shift in the celestial panorama is consistent with a spherical Earth, but would be inexplicable on a flat Earth. 5. Gravity. gravity pulls objects toward the center of mass. If the Earth were flat, gravity would not act uniformly across the surface. Objects closer to the edges would experience a noticeable difference in gravitational force, which contradicts our everyday experiences. 6. Air travel routes. Airplane routes around the world are based on the assumption of a spherical Earth. These routes follow great circle paths, which are the shortest distances between 2 points on a sphere. They consistently save time and fuel, further corroborating the spherical Earth model. 7. Weather conditions. The shape of our planet has a profound impact on its climate and weather patterns. A flat Earth would have drastically different atmospheric circulation patterns, leading to unpredictable and potentially extreme weather conditions. Understanding these changes from a physics perspective would be a monumental task. So, is the Earth flat or round? Well, it's a question that has puzzled and fascinated humanity for centuries. While we have overwhelming evidence supporting a spherical Earth, the flat Earth theory challenges our assumptions and encourages us to keep questioning. From a physics standpoint, the round Earth model aligns with the laws of nature as we understand them. Thanks for joining us on this thought-provoking journey today. If you enjoyed this video, give it a thumbs up, and don't forget to share your thoughts in the comments below. And hey, if you want to explore more fascinating topics in physics and our everyday lives, make sure to subscribe to Physics Daily. Until next time, keep asking questions, keep exploring, and keep expanding your understanding of the world around us. See you soon.